Hello again, it's Mrs. Sandra Rosa here to help you with Unit 3, Day 9 problem set. I'm going to help you with question 1 and also with question 2, at least to get you started. For question number 1, I'm going to leave most of the reasons for you to fill in, but I am going to talk about 2, 3, 4, and 5. So for question number 2, or excuse me, statement number 2, if you look at this, it says that DC is equal to CD, which is this piece right here. So because this piece is equal to itself, that would be our reflexive property. The next statement says that AD plus DC equals FC plus CD. Now, if you look at this carefully, you're taking what they have in terms of a given. They already have an equality. AD is equal to FC. That is an equality. And what they're doing is they're adding DC onto the left side, and they're adding CD onto the right side, which basically is the same quantity because we've already stated that in step 2. So when you add the same quantity to the left side and to the right side of an equation, that is called the addition property of equality. I'm just going to abbreviate that with equal sign. This right here, what this is saying, if you look at your picture, it's telling you that AD plus DC equals the entire segment of AC. And when you're adding and summing the parts together to get the whole, that is your partition postulate. And of course it says the same thing about FC plus CD equaling FD. So this is the postulate, the partition postulate. And then lastly, if you look at step 3, and I'm going to change color right here, on the left-hand side you have this quantity, AD plus DC. And if you notice, it's here. There it is copied. And on the right side, I'm going to change color. You have FC plus CD, and here it is down here. So basically what we can say is that AC is equal to FD by substitution because you have these two quantities that are also equal to AC and FD, and since these two quantities are equal to each other, so is AC and FD, and that is a substitution. And I'm going to leave you with the rest of the reasons to see if you can figure them out yourself, okay? I'm going to pause this and then I'm going to go down to question. Okay, so question number 2 gives us angle A congruent to angle D, so I'm going to mark my picture, of course. They also tell me that AB is parallel to DE, so I'll mark that, which means if we have parallel lines, I also notice the zigzag Z right here, so I'm guessing that we are going to have a pair of angles here and here that we could probably state are congruent because they're alternate interior angles. The next thing they tell us is that FE is congruent to CB, and that's only a part of this segment right here from E to B, and that is only a part of this segment from C to E, which means that is an indication, that is a clue that I'm going to have to use the partition postulate, and also because it is day 9, which is the partition postulate. So how are we going to do this? Well, the first thing we're going to do is state our given. So in step 1, we have angle A is congruent to angle D. We have AB is parallel to DE. And we have FE is congruent to CB. And that is all given. And then I'm going to go ahead and get those alternate interior angles, get those out of the way before I forget them. So in step 2, I'm going to say that angle AB looks like an F there. Okay, so angle ABF is congruent to angle DEC. And that is because if lines are parallel, then alternate interior angles are congruent. And now I'm going to begin the partition postulate series of steps. So the first thing I'm going to say is that BE is congruent to itself. So BE is congruent to EB. And the reason why I switched those, the order of those letters, is because it's in terms of the mapping, in terms of the correspondence. If you look at the name of the triangles, you have Well, in terms of the rigid transformations, you can look at this in terms of a rotation. So when we rotate this, BE rotates to EB. So that's why I do that. So this is the reflexive property. And then I'm going to take this equality right here. So they already have FE is equal to CB, and I'm going to add the same quantity to both sides. So I'm going to take FE, and now because I'm adding a quantity, EB, I'm going to take those segment bars off, and I'm going to set that equal to CB, and on that side I'm going to add BE. And again, when I add the same quantity to the left side and the right side, that is the addition property of equality. Step 5, I'm now going to use the partition postulate. So what is FE plus EB equal to as a whole? Well, if you look at your picture, when you add FE to EB, it equals FB. And at the same time, I'm going to do the same thing on the other side. So when I do CB plus BE, that's going to equal CE, and that's my partition postulate. And then step 6, I can go ahead and use substitution and say that FB is equal to CE by substitution, which will now get me the triangles. Yes, because I have that third congruency. I already had the angle in the given. I got the alternate interior angles from my parallel lines, and I just got that side. So I'm ready to state that in step 7, triangle AFB is congruent to triangle DCE by, and let's take a look at our picture and our markings. You have 2 angles and a non-included side. So they're going to be congruent by angle, angle, side. And you can see it from this way too. There's my angle D, there's my alternate angle E, and then the side CE that I got equal. So it's an angle, angle, side congruency criteria. And that proof is done.